Yeah, so this is a presentation mostly focused on art. My name is Joachim Barum, and my colleague here is Vojislav Dimitrijevic. We come from Artplant, which is a Norwegian-based company, and Russian as well these days. So, yeah, let's talk a bit about us first. Unity asked us to hold this presentation mostly oriented about art. So if you're a programmer and want to see a lot of fancy code, then you're in the wrong place. Yeah, yeah, I'll promise you will not see anything of this. I feel kind of lucky because my day I never see any of this. I mostly focus on this kind of stuff. So I'm a happy camper. Okay, Artplant. We've been around for 10 years now. We are a very art-focused company. We made a lot of games for the Norwegian market, so probably a lot of you have never heard about us. A lot of the games we've done is kids games and that kind of stuff. So, but lately we've been expanding and try to do a bit more international products. So. Yeah, we are like I said, we are a small company, so we have very few people. So we have to manage a lot of tasks. Each individual have to know more than just one small area. So, yeah. About me, I'm doing all the art direction in Artplant. I have a long experience with 3D and animation and painting as well. In addition to doing games, we also do a lot of painting and concept art for other games companies that hire us to, in the beginning of their project, to develop concept art and also illustration work. So I'm going to show you some of this stuff. Maybe some of you might not understand why I do this, but I will get to that later. So yeah, let me show some of the stuff I've done. So these are some concept arts that's been I've done for other kind of productions. So, for instance, this is concept art for a Swedish movie, actually. Brothers Lionheart, if somebody has heard about that. They wanted to make a new movie, and these were kind of drawings made to sell in the project. Unfortunately, the movie never came out. But concept art is good for that as well, because you can actually make concept art that you try to sell the project, and you can easily see early on if this is something you want to continue doing or if the project is dead before start. So yeah, these are some concepts for Battalion Wars, for a Wii game made by Nintendo. Kuju Entertainment hired us to do the environmental concepts to try to take the game a bit further from the first version to the next one. So this was a really fun project to work on as well. Yeah, and there was also some character concepts, all kinds of stuff for all kind of things. We also, in addition to games, we work with movies, commercial industries, and pretty much everyone who get in contact with us about art. We like to do this both because of the money, of course, but also because it's nice to try to do things in all kind of areas, because we feel it strengthens our work on the games production as well, to be able to do this kind of things, and it helps us getting better. So yeah, here's concepts for a toothpaste commercial, actually. And here are some concepts for a movie that was released in Norway. Actually, a big budget for Norwegian. And here are for a chocolate company. They build their chocolate in this building on top of the mountains in Norway. Yeah. More concepts. I could go on forever with this. We do so much of this that can't even imagine. These are for Sony, actually. They hired us to do some concept for an extreme sport game, which they considered doing. And like with the other ones I showed earlier, it was a good way for them to figure out that, no, we're not going to do this. It's too generic. And here for Pirates of the Burning Sea, and for an oil commercial, and for Funcom, Conan the Barbarian. Yeah, okay. So, well, the reason why I showed you this is because we feel that doing concept art as a part of production and have that expertise in a company is extremely important to be able to analyze the stuff you do so that you actually know how to take it a bit further and not just do the standard 3D stuff that you can do, and actually analyze it and see what you can do without actually creating it properly in the beginning. So, for instance, when we did the Dark Unity demo with the Unity guys, they hired us to do all the art assets and the art direction of it. So then we started, of course, with concept art the same way as what I showed you. And as you can see, if you've seen the demo, this is the first concepts we did, and you can see it's pretty similar to the final stuff that is on the screen. And after this, we start to do all the assets. And of course, it was a lot of assets to do. And once you've done doing all these assets, then you put it into Unity. And fortunately, Unity is a great tool for artists because you can tweak all the stuff and instantly see what you do. But there is, of course, a certain amount of stuff you can do initially before you need to have a programmer to take it even further. But for the programmer, it's not always that easy to see what am I going to do to take this actually a step further. So once we had this in Unity, of course, the first thing you do is you start to tweak the lighting and get the light maps in and tweak things to a certain level. And you can add the linear fog. But after that, then you start to question, okay, what can I do to take this further? And you discuss a lot of stuff. And in my opinion, then being able to concept and actually analyze what you have before actually doing it, then you can save a lot of time and also figure out what is actually smart thing to do before you actually do it. So, for instance, I did a quick concept paint over, and first suggested that we should have a shader on the sky that where we could tweak the amount of fog so it doesn't follow the linear fog of the rest of the scenery. And secondly, I suggested that we should have the glowing on the buildings that are far behind, that they should kind of protrude through the fog so that you doesn't lose the scale and the feeling of what is happening far away, even though we want to have a lot of fog. So, in addition to that, we wanted to have layered fog, because in a city like this, if you only have linear fog, it's it's very standard and kind of boring. And if you could have like layered fog in addition and maybe a separate color for each of these fogs, then you would kind of create this haze that lies on the ground in the city in addition, which makes the fog not just feel like a simple addition, but something that kind of makes more life to the picture. And yeah, and the reflection on the ground to make the feel of a wet street, and puddles, which is something that really helped the scene coming together, especially kind of to get all the building blocks to branch out and build them around so you get a better feel for them. So these puddles, well, what we said is that we don't really care if the reflection of them are unnaturalistic, but it's much better if they just reflect as much as possible, maybe even more than what you actually see. You can fake it, we don't care, as long as you just feel that they are extremely reflective, and because then they kind of gives a nice feel together with the rest of the ground. And of course, we wanted to have smoke coming from the manholes, glow. What I said here is that we would like to have glow, but we don't want everything that is bright to glow. We want larger objects, things that are close up, so that, because if you glow everything that you see that is bright, for instance, the windows far away, you will lose the whole scale of the city, so it kind of breaks the feel of it. And raindrops, small, not too much, because we didn't want this to be a tech demo showing rain and watery things, but more like creating a lively city. So, and of course, image color adjustment, which is easy to do in Unity, and even though you hardly saw the difference here, it kind of ties things together a bit. So if you see from the top to the bottom, there is really not that much difference, but still it's enough to make the city feel much more alive. And those things that I did here is just, first we did this in just doing concept on top of the image in Photoshop. It's like a 15-minute job, and once you've done that, you know much more if this is something that's going to work or not, and what you can actually leave out. So if you just see a short clip from probably many of you have already seen this, but maybe you can see some of these things here now that you maybe haven't noticed before, that they are actually in the scene. Especially you see the layered fog, how that actually helps the whole image looking better from it. Okay. So Battlestar Galactica. We've been working on this for more than a year now, and we're very close to being finished. As with everything else, like I said, we're a small company, and internally we're totally 5 artists working on this. But at the same time, we also did a lot of other stuff at the same time. So we had to find solutions that so that we could make a lot of assets in a really short time. And also, we like to kind of try to find simple solutions, not necessarily try to complicate things just to make it fancy. So actually a lot of the stuff we've done in Battlestar Galactica is actually quite simple. But if you make sure to have really good assets to start with, then you can actually do a lot with very little things. So the first thing we of course did when we started the project was discussing and talking with the programmers how to get a certain amount of tool set that we can use to create huge amounts of stuff quickly in Unity. And one of the things, of course, we needed a galaxy editor, because Battlestar Galactica, of course, happens mostly in space. So what we did there is we made an editor where we actually play the game, but you only what we see is the galaxy, and I could fly around in it. The whole galaxy is actually just quite simple. It's made out of 3 cube maps that follows the camera. One which is the nebula, and one which is the stars, and a secondary nebula so that we can create a lot of stuff with it. I'll show you a video while talking so you can see how it was. So this is what we have in Unity when playing around. And the changes that I'm doing here when flying around in this is only saved as just as data numberings, and based upon the certain assets that we have implemented into the game. So in total we made like just one star map, which we had the alpha channel that we excluded and included stars in, so we could have different amounts of stars. We also had 5 backgrounds in total for the entire game, and these backgrounds we could change colors, and only with that we could actually make and rotate them around, and then we could make. We have around 70 levels in the game, and you can actually not see any repetitiveness when playing. So you can actually do a lot with very little stuff if you just make good assets to start with. Yeah, so you can see here that I'm in real time just flying around and placing together these things, and I can just change the color, add amounts of stardust when flying, and smoke. And also, of course, we have in each galaxy we have two light sources, one for directional and one for the ambient. And with this we just created tons of levels. Of course, suns. We had to have suns. In Battlestar Galactica, the whole universe is the style of the game is quite simple. We don't want rainbow-colored galaxies. It should be much more realistic. So even though we have the possibility to do all kinds of suns and everything, we try to stay as make it as simplistic as possible for the style of it. Still, though, enough to so that you could see differences. Planets, we had around 10 planets, I think, and the only thing we could change on these were the colors and for the base color and the atmosphere around the planet. But this is actually enough for us to make totally different feel for each galaxy. So you can see here I'm just composing a universe based on one sun and a planet, and the backdrop, just moving and rotating the sun, trying different things. Actually, this is just regular rotating, stretching, pretty much just having fun. But even so, as you can see, you can make quite interesting results. Yeah, and here you can see I changed the whole universe from what you saw into a totally different feel with just a matter of seconds. And now it feels like a totally different place. And now I'm changing this into a more fogged area. You can see I add the secondary nebula, just pretty much just for a variety. And if I want to, for instance, change this into a totally different, maybe a more warm and lava-based place, you can see even just using the same assets, I'm just changing the colors, and whoops, you have a different place. So quite fun, actually. Yeah, so in total we have like 70 levels in the game, and they all kind of look like this. And eventually we also made this editor possible to make gameplay inside this as well. So actually all the gameplay is, much of it is edited in real time while playing. Yeah, so here you just see a couple of examples from just playing around. So within a few minutes I could have like twice as much as this. So quite fun, actually. Ships. I don't know, probably some of you know Battlestar Galactica from the TV series. We got the models from the TV series when we did the game. Unfortunately, the series don't really have that many ships. Universal, of course, started first. They didn't want us to add any new ships to the series, but it would be boring to play an MMO with only one ship, so we kind of had to add more. So, yeah, for instance, Battlestar Galactica itself, the ship, it's a huge model. I think the one we got from Universal that is being used in the series, I don't know how many million polygons it was, but it was insanely complicated. So we had to find a way to model this with less polygons. But of course, like you see on the Battlestar Galactica, it has a lot of those railings going around on it, which made it really, really hard to make it in few polygons. And also, this doesn't really work well when you make it in a game. For instance, if you see here, in the dark underneath of the ship, you can still see the sun or the light go across all these railings. And especially since we didn't add the real-time shadows in this game, because you rather want a lot of ships on the screen than and high performance than a few ships with shadows. So what we did here, we added an ambient occlusion map that basically works the same way as a light map. And when we added this on the ship, you can instantly see that the ship works much better in the shadowed area. And it doesn't look as, it kind of ties it more together. In addition to this, we wanted to add more stuff to make the ship feel a bit more rusty and used and kind of like it's been in a war. But it started to become a lot of different texture maps on top of each other. So what we did, we made something we called a combo map. So we had in the same map that we did ambient occlusion, we added on each of the RGB channels, we added a different map. So for instance, here we had the damage maps, which is just added on top of the ambient occlusion. So the ambient occlusion is in the red channel and this is in the green channel. We instantly get the ship to look a bit more broken and interesting to look at. All the playable ships, we use this one in so that the ship get more and more damaged while you play. So of course this ship stays this way all the time, but the playable ships they will get totally broken in once you have low health. And yeah, we also added rust because that kind of helped the whole feel, so you get a bit more color variety. And this is just one color, which is also added as one channel in the same map, but that we just customized this to be displayed as one color instead of just black. We use this one also for the playable ships, so that they are extremely rusty, and you can of course pay money and get a ship that is clean and better. So yeah, all these three maps just into one map, combination map, and so actually that map kind of helped us a lot, that kind of shader to make the ships look more interesting. And of course, glow map on top of this to give a good feel of scale, and the ship becomes a bit more live with lights. So yeah, like I said, we had to design some ships in addition to the ones that are in the series, because that's simply not enough for a game. So that was actually a challenging task, especially because Universal have their own view to the series, and of course they love it a lot, and all the people that have been part of making the initial design for the series, they had their own saying to what we made for the game. So of course they had to be able to they had to approve everything we made. So it was quite a challenge, but happily that turned out well too. So here you can just see some of the ships that we designed, trying to keep it in the lore of the original series. So we had small ships, and you have a bit larger ships, and all of these ships, as you can see, they have the rust map, and they have the ambient occlusion and everything, and kind of gives a nice quality to the model. And So in total, we made 18 playable ships that are that you as a player can choose from, 9 from each race. Yeah, here are some of the huge Cylon ships. Cylon ships were quite a challenge to design because it's supposed to look alien. At the same time, you should see it's a ship. It's not supposed to have an engine, but it's still supposed to have an engine, and it's not supposed to have a cockpit, but you're supposed to feel that somebody's driving the ship. So it's very small things that especially the guys who made the series believes in, and had to make sure that we kept. And here are some of the huge human ships. Okay. Yeah, the last thing I want to talk about is marketing materials. This is also quite important when you do a game, because it's not only once you have the game done and everything, it's important that the marketing material just doesn't look like regular shots taken for any kind of reason, but that you actually make proper screenshots and proper videos. And I think Unity is a great tool for this, because a lot of the big games companies, they have this tool for setting out cameras, and so that you play the game and you put pause, and then you can find a better camera angle that works with as a screenshot, and you kind of compose the whole thing. And you can actually do the same thing in Unity. So what we did is, when you play the game, hit pause, and you can move the camera around, maybe add a couple of things that are in the game, but it's very hard to actually achieve just by random chance. And especially when you're going to take a screenshot, if you're going to try to capture that moment, you will easily end up playing for hours and actually not get anywhere. So this is a really nice way to prepare marketing material. Put the game on pause, and you can go nuts with everything, and then start playing again, and everything just disappears. So and then you get shots that really look interesting. Yeah, here's different screenshots. Yeah, so then I'll leave the word to Voya. We actually didn't have that much animations in Battlestar, because as you know, it's a space shooter. So he's going to talk a bit more general about animation and how the different kind of ways you can do it in Unity, and which he likes. So yeah, thank you.
Hello. So as Joachim mentioned, I'm going to talk about animation and animation methods in Unity. So there we go. First about me. My name is Vojislav Dimitrijevic, but out of obvious reasons, everybody calls me Voja. I'm lead animator and lead technical artist in Artplant AS, but my main focus is and always has been animation. And during when we approached Unity and when we started actually using Unity, that's when it triggered my interest in actually getting more techy and geeky. And that's when I started experimenting with scripting, also in 3ds Max, which made it possible to actually create custom tools. When I saw how that is good, and that you can actually customize your tool that you're working for your current production, then that triggered a series of questions. What if I do this? What if I do that? And up until Unity, no other tool allowed to for artists to actually dare to venture into technical experimentation. And that's why I really, really love Unity, because it makes it possible for artist-oriented brains to merge towards the programming part of the production, and it makes it easier for the whole team to actually develop a much better looking product, because in every production the biggest problem is communication between artists and programmers, because sometimes it appears that we're speaking completely different languages from different galaxies, and Unity managed to actually bridge that point, because it offers enough flexibility and it's easy enough to approach technical details from an artist's standpoint, and programmers at the same time can actually see what we mean, and we can directly interact in Unity. So basically, as Joachim said, animation is such a good tool. Unity is such a good tool that when I heard that we need to hold a speech and that I need to talk about animation in Unity, I was pretty much baffling my brains out. What am I going to talk about? Just drag and drop a file and hit play, because that's how it works in Unity. But I remembered that we actually experimented quite a lot, and we tried out different techniques, which might be useful for people to actually hear and maybe think about, because they're not usually used. Unfortunately, they are there in Unity, but they're not used enough currently, and maybe this might trigger somebody to think about it and use those tools in a better way. So that's why it says, know your tools and needs, and you always have to prepare and plan your production. So I divided, I chose 3 methods in Unity. First and most obvious one, I'm not going to talk about plain animation. You just create your animation in your animation package and you put it in Unity. That's straightforward and everybody knows that. I'm just going to talk about things that you can do to speed up workflow, to minimize the resources needed for achieving, in many, many cases, better results than having 20 or 50 animation sets per character. So first and foremost, additive animation. Every example that you see, they will mention just you can use run loop and then add additive animation on top to bend your character going left and right, and pretty much everybody sets it down to that. But on the contrary, you can actually make it much more powerful, but it requires for you to, as an animator and as an artist, you need to think about it ahead. So that's why you need to play with Unity and enjoy it. It requires a layered set of thinking. Let me just show you a very, very simple example. We have Admiral Adama having his just normal, most default looking breathe cycle, which everybody needs to start with, because that's what you need for any kind of idle. And usually what the production requires is you would need one animation, one full set of keyframes animation for character for each kind of idle, which takes a lot of data and takes a lot of animations. Instead, if you take your basic stance position and then create a lot of different additive animations, for example, body movement, head movement, and hands movement, and you just put them on, there we go. If you add body movement, upper torso, for example here, it's just upper torso and head, and some arm movement, which in terms of keyframes is much less data, it's much simpler to do, and it's much simpler for the engine and computer actually to handle. But you get the same result. Actually, you get a better result, because what you can do is you can create a set of additive animations that go on top of your breathe, and you can actually add a little script that plays and loops your breathe animation underneath, and you randomize and trigger whenever you want randomly those additive animations. Then you create non-repetitive kind of motion. Okay, this one is repetitive because it's a short example, but it's just a layered style of thinking to minimize resources, and you actually go from having, I don't know, 10, 12 different full animation cycles just for idles to one full animation and a couple of short additive animation cycles that you put on top, and you randomize through them. You get the same result, less repetitiveness, and yeah, everybody's happy. Programmers are happier then. Another thing that we used actually in Battlestar was you had a lot of situations when you needed to approach an NPC and talk to him, which of course sounds simple, but it requires a lot of different situations, because automatically you need to think about where is your character going to be oriented, how is he going to be looking, where is your NPC going to look corresponding to your player, and also you have to cover talk happy, talk neutral, talk different kind of expressions. And once you add all those things, you will again add another 15 to 20 animations to your character set. Instead, what you can do is just create an additive animation for the face. Again, you're saving up keyframes, and what you can do is just put it on top of your character and trigger it in the situation when it's needed. Again, you're saving time, money. It's much easier to create just a facial animation, and you can actually just focus on it. And again, you're saving resources. So that's pretty much the simplest use of additive animation, which has been in Unity since, I don't know, I think before version 2. But very rare people should use it more because it saves resources, saves production time, and you can actually get much better results. The other thing I want to talk about is use of locomotion system. I don't know if many of you are aware of or know it, but it's a really good scripting set of scripts that you can just add to your production. And it's a very powerful tool that speeds up production and, in this case, drastically minimizes resources. It's well known that if you want to have an animation set for a character, you need a base set of about 8 animations, which is walk, run, idle, transition animations, turn animations, and again, the list just kind of expands very, very quickly. With locomotion system, it's extremely easy to do a very functioning character in your game. What it does is it creates an IK setup for your character's legs, and that eliminates completely foot sliding. So you don't have to think about linear, non-linear movement, which is usually the biggest worry, because if you create an animation loop, you just give a distance through which it moves through a given loop, and that distance is covered in a linear form, which is not how humans move. That's not how we move at all. We always have a beginning of a motion, and then ending the motion. So that's completely impossible to do in games, or you can, but it's very difficult. With locomotion system, you don't have that problem because he keeps your feet planted, your character's feet completely planted at the floor automatically. You don't have to do anything. You just set it up and it does that. So it adds a lot of freedom, and it also automatically creates and calculates distances needed for your loops. So in that respect, it's a very, very powerful tool. Another thing that the IK system and the whole locomotion system does is that it automatically detects surface that your character is walking on, which means that no longer you have to worry about slopes, stairs, or anything like that. Because if you know, for a very long time, many of the games solved the stairs problem by just adding just a slanted slope in collision. And when you walk up to it, your feet go through the stairs or float around, and it just doesn't really look right. With locomotion, you don't really have that. And let me just show you an example what I mean, why it's so powerful. What you're going to see here is locomotion system character setup with only 2 animations, just 2. We have an idle and a walk, absolutely nothing else. And of course a character controller so that I could walk him around. So he plays his idle, and then I start walking him around. No foot sliding, automatic detection of the stairs, turning is pretty much okay and normal. Of course, it doesn't look perfect, but we are talking about a character animation set that's functioning in your game, and you can play it and you can walk him around with 2 animations. If you compare that for your game, which might have 50 characters, and you slash down the production time and the production cost per character, you need 2 or 4 animations instead of 20. We're talking about really, really serious numbers. And especially we had to do those things, as Joachim mentioned, if you have a short-term production, you really have to find the tools that can do those things. And this is a perfect tool that it's not resource hungry, and it definitely justifies the difference as far as resources go. The final thing I wanted to talk about is something that annoys me a little bit, and that's Unity has a really brilliant physics system that is not being used at all. If you Google up for Unity physics tutorials, all you will find are boxes and spheres hitting the boxes and falling and spheres rolling and things that we've seen all around the place, and basically you can't do anything with that. It looks cool, it's fun to play with, but it's not really usable, especially not for characters. Well, it's not really like that, and it's really, really simple to use it. It's just getting a right mindset, and again, that's why Unity is so important. It offers a completely new set of production thinking, because it offers artists who usually will never venture into technical bits of production. They can actually think in a more technical terms and cover things that, like this. For example, if you would mention physics to an artist, he would run away before, but here it's not the case. I divided physics in 2 sections. First one is basically you can use them on your pre-animated characters, which means you animate a character in your 3D package, export it to Unity, and then you can use the physics to set it up for accessories. Accessories can be capes, clothing, swords, or even body parts. If you have an alien with a jiggly antenna on top, you just add it, or if you have a horse with a tail, you add it. And once it's set up, you get automatic secondary motion, which works in any kind of situation, and even better, if you want to use, you can actually use those accessories to have collision detection with your environment. So no longer you have a problem if your character, well, let me show you. We have a little dude here. Blue boxes represent bones that you would create and animate in your animation package. Gray boxes represent the ones that were set up with physics. The way I would use this, for example, is I animate my character, and I would create, let's say, a set of 20 capes that you need to choose from when you customize your character, but they're all controlled with the same bone system. And all you do is you just choose your cape and you play the animation. And when you play it, what you get is a completely natural motion of the cloth that you could never ever get in any other way. I mean, you can simulate it in your 3D package, but then you have to think about looping. And as soon as you need to loop your animation, it loses the dynamics. So basically, if you were running and your character stops, the cape will stop. It will have no inertia, it will have no secondary jiggly motion, it can't have wind. For example, you just enter a windy area and your cape starts flying around. And all you needed to do was to set your cape to use physics for your motion. Again, a very powerful tool that can save production, increase the production quality, and saves time. The second thing that I wanted to talk about as far as physics go is a little bit more demanding as far as technical way of thinking goes for artists, because it requires thinking. I know that this looks the same as the previous one, but it's really not, because what we did previously, we had a pre-animated character which already has a fixed motion and look to it, and then you add physics to his accessories. But here what you can do is actually create, for example, this. This really doesn't look impressive at all. It's a jiggly little ball that's moving a tentacle up and down. So in 3ds Max, I would just create this as you see it, and I would export it. The only thing that's animated here is the first box. It goes up and down as rotation, and the main body movement. I was trying to create and was going in the term of thinking of a jellyfish / octopus movement. When what I would do is then put it into Unity, create a link between those boxes or bone links that you would see in the previous one or in here, with just a simple hinge. There's nothing. There's just a rigid body for your bone object and a hinge between them. And you can add the limit of rotation. That's it. That's everything that's been done. It's just adding hinges and the rotation limit. And I created prefabs of that and then just copied them all around and hit play. What you get is a really, really beautiful smooth motion in real time. Because it's all prefabs, it's not expensive to do. And another thing that's extremely impressive, for me at least, is I intentionally added and left them all in sync. But if you will notice, your eye doesn't object to it, your brain doesn't object to it, because it's not perfectly identical. It's impossible to do that with normal animation, but if you use physics, it does enough little irregularities to create a believable motion. So even though they are all in sync, doing exactly the same motion at the exact same time, it doesn't look unrealistic. It doesn't look like a robot. It looks more natural and more flowy. And that's exactly what the physics approach gives you. It gives you that little fine touch of realism. And of course, the added big bonus is represented by this ball, which is actually going through them, which doesn't affect the animation, but completely affects and interacts with the tentacles of these real creatures. And you get results that you would really not, I don't really know how I would effectively be able to reproduce something like that if somebody would ask me in any different technique. So in a way, it's a little bit more complex to not set up. It's not complex to set up. You just need to think in a different direction. And that's why I really, really find Unity an amazing tool, because it's incredibly inspiring. It's incredibly innovative, and it's bridging the gap between art and technical approach to video games. And I think that if people start using these things in a more unified way, we're going to start getting much more better-looking games with unprecedented level of detail and in motion, in graphics, and in all other aspects. So yeah, basically that's pretty much my part as far the animation goes. Thank you.
Yeah, of course, if somebody has any questions, feel free. Preferably not very techy questions. So yeah, also if you want to contact us, these is our email addresses, or feel free to visit artplant.no, or yeah, or us here if you want to have a talk about anything.
My question is in regards to the IK animation, the two-step animation with the character going up the steps.
Yeah.
First of all, I wanted to know was if you had any reference to any tutorials that explain that, and secondly, does the IK compensate for the height of the steps, or do you have to set the height of the steps for the IK?
You can actually do it completely in the locomotion system, because the way it does is you define the leg joints. So you define your upper leg and your ankle bone, which is basically your foot, and it creates an IK setup. You then define the lower detection position, basically the size of your foot, how much you will have in contact with the surface, and it does everything automatically. What you can specify is to avoid unnatural surfaces, because if you run your character and he runs into a 1 meter slope, you don't want, you don't want his hips breaking and his foot landing here. So that's the parameter that you have, and you can actually set it up to whatever is desired, and it depends on your rig and design of your creature, so you can experiment, play around, and see what result is the best one. But it's really easy. It's just one parameter. You type it in, you see what works. There you go.
I wanted to ask you guys about, with the Galaxy Editor, you had the planet, you had the stars and nebulas, but you also had, when you were moving, the debris that really gave you the sense of movement.
You mean the space dust?
The space dust.
Yeah.
Is the space dust, are you guys using prefab game objects or using an image that's procedurally generated? What is that that's being generated at that moment?
It's particles that follows the camera, so that it's only actually around you. It's not really in space, if you know what I mean. So, yeah.
Can you give us a sense of an art budget for one of these ships that you created, whether it be the Battlestar or one of the smaller types of fighters?
You mean how long we used on making them?
How many triangles, what size the
Yeah.
textures, that sort of thing?
It depends on the size of them. Of course, the smaller ships, they are more baked with one texture and rather quick to make after the design process of finding the design. But for instance, Battlestar Galactica is like at least a couple of weeks of work, because there's a lot of looping textures, because you need to be able to fly up really close and see each texture in high detail. So we had to use looping. So it's more like creating a world, but you create a spaceship instead. So in total, I guess the Battlestar Galactica is something like 3 image atlases and the looping hull texture, and then the combo map, which I showed you. And yeah, around 20,000 polygons on LOD 1 for that one.
Okay, another question here. I was wondering, in regards to the ambient occlusion that you showed in the beginning, I could see that you baked that onto to an image map. But I was thinking, had you done any like test or considerations on maybe baking it onto to the vertices instead as a vertex coloring, considering that that tends to be cheaper than doing it the image-based way?
Yeah, that's a good point. I'm sure that would be possible. Of course, you mean vertex, to have it in the vertex coloring. Of course, the problem then is especially lodding, because the ships change the amount of details from LOD 1 to LOD 2, and then the ambient occlusion will kind of change radically as well. So we would much easier see the lodding. And also, since we had to add like dirt maps and damage, it felt natural to add them all into one thing. And also the way we solved it like this, you don't really see the loading of the ships, so the whole transitions are much more natural, because actually the ambient occlusion from LOD 1 is and the damage is projected onto LOD 2, so that you kind of get the sense that there is details there that actually are gone in the second LODs and so on.
I've been converting parts of San Francisco into scenes for Unity, taking like Street View and then modeling it and then pulling it out and texturing it. And nothing I've made looks even remotely as good as Dark City. But the first thing that I thought when I got kind of frustrated with this process and how intensive it was is, if only I could procedurally generate from, say, a Google map or a cleaned up version of Google map using like blocks or pieces like what you're doing. Have you guys, because similar to what you're doing with Battlestar, where you had tools that allowed you to make a lot of stuff quick, have you guys worked with anything where you could make scenes like Dark City and have those elements be procedurally put together?
No, we haven't, because the Dark City is kind of a small demo, so it was never actually necessary to make a procedural tool for this. I would really love to work on a game where we actually did this, because I think it's a real cool thing to do. I remember when I was at the GDC in February, I think, some company with the Unreal Engine had made a really great procedural tool for making cities, and it looked like a lot of fun. So it's I'm sure it would be fun.
Cool, maybe I'll ask you about that later. Thanks.
Yeah. Oh. Okay, no more? Oh.
So is it mostly you two guys, or do you have also prep people and people who are there to optimize things? Like, what is the workflow like?
Yeah, we actually have around 20 programmers in our company, so which are all have different areas of expertise, like server programming and everything. But we kind of, since we have been doing Battlestar Galactica, we kind of expanded a bit, so people have sort of their areas. And but the artists, of course, when it comes to optimizing, we have to work together with the programmers to find the best solutions for everything. So it's not like we go nuts and they have to solve it. Though I would like that.
And must have a kind of a two-part question. The first part is, do you find is there any advantages to importing animations from, let's say, Blender or Maya versus doing something natively in Blender? And the second part of the question is, I guess, the optional answer, but if you get really, really good at this, how much could you expect to make financially?
What do you mean? Expect to make money-wise?
Money-wise, yes.
It depends how good you are, but
Like awesome. Let's say you got awesome at this.
you get really awesome and you use a free tool as Blender. You won't get rich enough to buy a Ferrari. That's it. I mean, that's the bottom line, because video games industry is not about money for artists. It's about money for managers and producers and publishers.
No, I was actually specifically a number. I wasn't talking about getting rich per se, but I was talking about an actual number amount as far as somebody who got comparable, let's say as good as you are, perhaps.
Thank you. But it depends. Wait a minute. This is confusing me. What was the first part, and then I can.
The first part of the question was: did you find any benefits versus doing animations natively in Blender natively in Unity versus importing them from some other program like native, like a Blender or something like that?
As far as I know, you can't really still do proper animation and full-on character animation in Unity. It's only good for additive and things that I've shown that you can actually think about, brainstorm, and then experiment and create new things. So for interactive stuff, and again, it's animation that's not supposed to look cool on its own, but it actually needs to serve a purpose in a product. That's why I showed the third part of the physics where it actually interacts. You could actually make a much cooler looking animation of a jellyfish in Maya or in Max with much more complex constraints, tools, and very, very complex rigs. But it all comes down to your needs. And that ties into your second question, or the second part, how good you are. In animation, it doesn't really manage, I mean, of course, up to a certain point, how good you are is that you make things look good. But the second part that really makes you stand out in a professional view is how good it looks according to the project's needs. So if you create something that's utterly amazingly beautifully looking, but it never gets used and it never gets seen, you've wasted time, you've wasted money, and then you're not good. So it's finding a balance, a perfect balance between the quality, what's going to be seen, and what the production needs. So, and as far as how much you can make a decent amount of money that you can live a normal life. So,
like a garbage man?
Sorry?
Like a garbage man?
Yeah.
That's cool, thanks.
We sleep a lot, so you can dream.
Thank you.